All right, so 13.1 is a review of vectors. Let's see. Did anybody not take Calc 2 at UV? You didn't?
No.
Okay. So I might have to get you some extra videos because
Okay.
we're going to do a quick review of things that assumes you know some stuff that you might not know.
I've taken engineering physics
Okay.
up to 3, and then I've taken a bunch of engineering courses. with
All right, so
vectors.
you might be okay, but talk to me after class and let
Okay.
me know if it feels like you need some extra.
Okay.
Because our ordering is a little bit different, and so we're assuming you see this, whereas a lot of classes, this is the first time you see it. Okay. Review of vectors. So I think the basic addition and stuff will be fine. I just don't know if you remember the equations of planes and stuff like that. But we'll get to that in a minute. So let's just remember a few things. So if you got a vector v here, some vector u here. I just randomly drew these, so don't be concerned that there was some idea behind this. What's the vector 3u look like? Right now, I'm just assuming these vectors are in the plane, right on the board, but they could be in three-dimensional space, and you do the same thing. So what do I do if I want 3 times a vector? What's that look like? It's the same vector, only same direction, right? And so maybe even before I do anything else, what is a vector? It's a object that has a direction and a length, right? It doesn't, so this vector is the same as, assume I'm drawing the exact same thing, as that vector, right? It doesn't matter where they're at, it's just a length and a direction, right? And so those are all the same. And so if we want 3u, we just take our u and we try to go in that same direction, right? And we just go 3 times as long. I'm guessing that that's it. Just 3u. What about u plus v? So how do we add vectors? So this is all just, right, the idea of adding them graphically.
We put the tail of the U on front of
Right, so
the
you
head of V.
so just work left to right, right? You start with whatever vector, so u looks like that, right? There's u, and then we just tack the v onto the
On
tail of v to the head of u, right? So v looks like this, and so again, I'm not worried about too much. So there's u, there's v, so what's uv then, or u plus v? The vector from the start of u to the end of this, right? So this guy right here is u plus. Does that all look familiar?
Yeah.
Right? Okay. So we don't really do a ton of it algebraically anyway. So let's assume we're here in R cubed. So what's that mean? 3-dimensional space, right? So you got x, y, and now z. Let me just make sure. So I am always going to draw my axes with x coming out, y here, z here. If you want to draw them in a different order, that's fine, but you got to make sure you're still satisfying this right-hand rule. So a lot of people want y and x here. You can't do that, right? You could do what? You could do x, y, and then z coming out. So this could be x, this could be y, and then z could come out if you want to do it that way. But most of the time, we're going to be thinking of functions of x and y, and so the z will be sitting up, and so I want to draw things like this. So here's our setup. So what is I as a vector, right? So we draw vectors with little arrows over them. The book will draw them as bold vectors, but it's hard to draw something bold on the board, so I'll always draw arrows over them. So what's the vector I, the vector j, the vector k, and this is, again, I'm jumping ahead a little bit.
I is 1, 0, 0.
1, 0, 0,
And then J is 0, 1, 0.
0, 1, 0,
And then 0, 0, 1.
0, 0, 1. And what do they represent graphically here in the plane? So
Each axis.
1, 0, 0, and not just the axis, but a vector of length 1 down the axis, right? So there's I, there's J, right? And then there's K sticking straight up. All one unit. Okay. Does that all look familiar? And so we write vectors in different ways. If I'm in 2-dimensional space, I drop off my z components, right? And so this is still I, 0 or 1, 0, j is still 0, 1 in 2 space. Hopefully that's not too difficult. Let's just do this. So if I represent my vectors component-wise, 3, 1, negative 2, v be the vector 2, negative 1, 0. Okay, this is just to make sure we're okay. If I want to write this in terms of I, j, and k, what does this vector become?
3i plus j minus 2k.
3i plus j minus 2k. And I guess I'll do this one, 2i minus j, and then no k, right? Does that make sense? And so, you know, I don't really care what form you use if you want to, you know, write them in terms of these component, or this unit normal vectors. You can always convert things over if you want to leave them in this form, but you need to at least be able to read them in both forms and move to the form you're more comfortable with and work there. Okay? So with this in mind, what is 2u minus v equal to?
So be 4i.
Yeah. Just take your time and write it out. And you can write it in terms of I, j, and k. I'm just going to do it in this other form. And so I'll get 2 times 3 minus 2, right? That's the first component. Right? 2 times the u value and then minus that, and then 2 times 1 minus negative 1. Okay? And then 2 times negative 2 minus 0. And again, this is one of those things where if you start feeling comfortable, you're fine to do it in your head, but it's really hard to give you any credit if you do it wrong. So be very careful if you're going to do the arithmetic in your head, or just include a middle line. That way I can say, oh, they dropped a sign or they screwed something up, and give you most of the points. So what's this end up being then?
4i plus j minus 4k.
Not plus j, 4i plus 3, right? It's 2 minus negative 1. So plus 3, is that okay?
Yeah.
And then negative 4,
Yeah.
is that okay? All right. What else? So suppose I got, let's do it this way. So 2-dimensional vector u, 3-dimensional vector v, 3. Again, I'm trying to move through this quickly, so if you feel like I need to slow down, let me know. What does this mean? When I say absolute value of u, you might, I think the book always uses double brackets. I just use one. Once I see it's a vector, right, the only meaningful thing for absolute value is what? What do we call it? Magnitude. And so, you're welcome to use whatever notation you're comfortable with. If you've already, fallen in on one, that's fine. Just make sure you're doing it. What's the magnitude of a 2-dimensional vector? Square root of
u1 plus u2.
u1 squared.
Oh, yeah, plus.
u2 squared, and then same thing here, but just with 3 terms, right? Does this all look familiar to everybody? Okay. All right, so let's do I'll write it this way. U is a unit vector if, so what does it mean to be a unit vector? Its magnitude is
1.
1. So vectors of length 1 are unit vectors, and so those are useful because they're just pointing, right? And then we've scaled them all to size 1, and so they're really the vectors we think of as just saying, okay, we're going in this direction, let's get a vector of length 1, and then we just have sort of normalized it to that. Okay? This will be really important when we get to defining curvature later on, but for right now, it's just a simple exercise to do. So let's do this. Find a unit vector in the direction of v, and let's just 1, -2, 3. Okay. We got a vector 1, -2, 3. I want a vector of length 1 that's pointing in that exact same direction. Okay. So, how do I do that? Out of direction v, we know that multiplying v by some number can stretch or shrink it, right? And so if I want to get a vector that's pointing in the same direction as v but of length 1, I want to multiply it by something, just v by something, and what do I multiply by?
Can you just multiply by like 1, 0, 0? If you're trying to find,
Well, but no, I mean, it shouldn't be a fixed thing. You're taking this vector, right? What's the length of this vector? So say I have a vector here of length 10 billion, okay? How do I scale it back to be a vector of size 1? If it has length 10 billion, I want it to be length 1, I divide it by
Divided by
10 billion, right? Whatever its length is. And so I take v and I multiply by 1 over the size of v. Does that make sense?
yeah.
And so let's work that out. So v is 1, -2, 3. What's the size of v? The magnitude of v? Square root of
14.
1 plus 4 plus 9, so square root of 14. Squaring all those. Does that make sense? What's that? Well, that's fine for the most part, but I'm going to just write it like this. 1 over root 14. If you left it this way, I wouldn't complain. That's fine too. Okay? All right. Okay, so I think that's all the really like basic stuff about vectors, right? How do you add vectors? What's the length of a vector? There's two important operations on vectors. There's a dot product and cross product. Those both sound familiar. And so the dot product's pretty easy to compute. The cross product becomes a little bit messier. But those are the two things we're going to talk about next time. So I think rather than start that with a couple minutes left, let's just stop here for